Good afternoon. I'm Terry Ray, and I'm a science coach for Durham Public Schools. And today we are at Durham Public Schools Hub Farm at the pond, and we are going to do some water quality testing. You may wonder why we're doing it at a pond, but this pond actually feeds into a stream that goes into the Eno River. And if you don't know, the Eno River feeds into or flows into the Falls of the Neuse Lake, and the Falls of the Neuse Lake provides water for Wake County. And so scientists like to make sure that the water, though it may not look clean for us to drink, but we need to test to see if it's clean for the environment and clean for the animals. So today we're going to run lots of different chemical tests. Scientists would also run a biological test. They would take nets out, and we would collect all the organisms that we could find, and we would count them to see how many organisms we could find, whether they were tolerant or intolerant to pollution. But we're not going to do that today. The pond is up because we've had a lot of rain lately. Typically we want the water to be about a pH of about 7. We have done it out here a couple of times and found that the pH is 4, so we're trying to kind of figure out why the water is more on the acidic level than the more neutral level. We're getting ready to do the pH, some of the chemical testing, and I'm going to start with pH, but first we have to get our sample water. And here at the Hub Farm, we're on a deck that was designed by NC State engineers, and they made it so that we did not have to get on the banks to try to collect our water samples. So we pull this grate up, and you can see that underneath the dock we have a lot of water. Sometimes we can see organisms or fish and turtles swimming around in here. Looks kind of murky, but we're going to get our water sample. And one of the things I'm going to do while we're testing for pH is I'm going to put a thermometer in this water, and we want to gauge the temperature of the water. We want to know the temperature of the water because that affects the oxygen levels, which we'll test in a little bit. But if the temperature is too hot or too warm, the oxygen levels will go down, and that's bad for the organisms living in, and especially the fish living in the pond. So I'm going to put a thermometer in here and check it. It is a Celsius thermometer. The way I try to remember Celsius is a little saying I was taught was 30's warm, 20's nice, 10 is cool, 0's ice. And so we want the water temperature to be nice. So I'm going to put the thermometer in, and we're going to do the pH test. Let me find my thermometer. But pH kind of measures, the easiest way for you guys to notice, pH measures kind of like the chemicals that are in the water. So it tells us if something is neutral, which is okay, if it is a base, or if it is an acid. And typically acids run from about 6 down, and bases run from about 7.5 up. And the higher you get with the base, the worse it is. The lower you get with an acid, like if it's a 1, that's very dangerous. So we're going to take what is called, there are 2 ways to test, and I'll show you. This is litmus paper, and it's an indicator paper, and it will change with the color of different chemicals. Get it open. Maybe. And you can see. And what we would do is we dip it in the water, and once we dip it in the water, there's some color coding here, and the color it changes, we can match it up, and we can determine the pH level of our water sample. And you can do this at home with any type of water. Scientists would go out to the Eno a lot. The state park rangers would go out, and they would test the water out there to make sure people are not dumping chemicals and things like that into the water. So I'm going to just dip it in here, and if you can look, that's the strip, and I would take it and I match it to whatever color shows up, and this is really good. This is a 7, which means that it's neutral. So I guess with all the rain we have had lately, it has all the water running in, and the water will run in from up hill. It'll run all the way down into this pond. The water has diluted a lot of the acidity in it, and we now have a pH of 7. That's neutral. That's really good. So it's really good to see that here. All right, now this test is what we call a turbidity test, and this little thing that I'm holding here is called a Secchi dish, and if you can see, it's black and white. And turbidity is probably a hard one for people to understand. It's the cloudiness of the water, and it's how much light can kind of reflect or light can go down underneath the surface of the water. And when you get a lot of dirt, sediment from hard rains, a river, you may notice, is very brown and murky looking. And that's okay for a while. What we don't want is to see brown, murky water with a lot of soil and sediment in it for long periods of time, because again, when that sediment is in that water, the oxygen levels will go down. And if it continues, it could actually cause the death of the pond or the stream. So this is a Secchi dish, and normally we would be out in a boat. We can't get out there today, but I'm going to lower this dish down into the water. And when I lower it, somebody will look with me, and we will judge when we cannot see this disc. And once we determine we cannot see the disc anymore, we will raise it back up, and there's some little marks on here, little black tiny dots for me, and they're about 25 centimeters. And so we will measure, we will determine how deep this Secchi dish can go. The deeper it goes, the better. If I could only get it to about right there, or about 25 centimeters, that's probably not good. Now, if you look at the water, most people would tell you it's dirty, it's brown looking, and it's going to have a high turbidity. But you really have to test, because our eyes can be kind of deceiving. So I'm going to lower this down. Very easy. We don't throw it. And again, it would be better if we were out in the middle, but you lower it down. Very easy. And then, I don't know if you can see, I can barely see it now, but I'm going to keep going a little bit. And I can't see it now. So I'm going to pull it up. And I'm going to find my mark, kind of the wet part of it, where it's kind of changed colors, which is about right in there. And I'm going to look, and that's 25, 50. We're really close, probably about 65 to 70 centimeters, which is, I've done this before, and this is about a meter high, so we can get this down about a meter. And so for this pond, it's been fairly consistent in all the years that I have tested this. It has been fairly consistent with about a meter or a little more. So even though it looks cloudy and dirty and everything, it's actually got a pretty good turbidity level. And so if you went to a lake or you went to a river, and the marine biologists, state park rangers did this, they would want to see it go down as far or as deep as the water to try to make sure that there wasn't a whole lot of sediment building up in the lake or the pond. All right, we have put a thermometer in the water to test the water temperature, and if I look right now, it's a little hard to see, but if I look right now, the water is about 16 degrees Celsius. So remember the saying, 30's warm, 20's nice, 10 is cool, 0's ice. So the water feels cold, but it's actually a very good temperature for the organisms that live in there. So it's 16 degrees Celsius. If we took the air temperature should be higher than the water temperature. And that's because water has a high specific heat. It takes a lot of energy, lots of energy, to heat up water. And so one of the things biologists would do is they would make sure or test the water temperature to make sure it's not getting too hot. So if you went to a puddle that had been out in the sun and you did the temperature, the puddle would be extremely hot. That is not good for organisms. And now I'm going to walk over to the grate again, and I'm going to do a test for what we call dissolved oxygen. And that's needed for the organisms to live. Now I'm not using my sample bucket because you need to get dissolved oxygen straight from the stream or straight from the water source. And so I'm going to open the grate again, and I'm going to take this tube and I'm going to dip it down in there, and I'm going to fill it all the way to the tip top so that hopefully all the air bubbles are out. And I have 2 test tabs in my hand. I'm going to put them in, and I'm going to shake it. Now this takes a while because they don't dissolve very easily, but I'm going to shake it until they dissolve, and then again I'll have a little color chart that I can use, and I can tell the amount of dissolved oxygen. Remember, if temperature goes up, dissolved oxygen goes down. If turbidity is high, dissolved oxygen is going to go down. So dissolved oxygen goes down when everything else typically goes up. And we want it about, I think about a 4 or a little bit more. This pond's been running a little low over the past couple of years, but when we look at the macroinvertebrates, we can see, like right now you can't, but I can see about 2 or 3 turtles, snapping turtles out. We've caught fish. The geese, you've probably heard coming in and out. We found lots of macroinvertebrates. So far that level has not hurt this pond. So the grate goes up. And I just lean down and I fill it to the top, and then I add my tablets. Marine biologist and the state park rangers probably have a fancier test than I do, and then we just shake, and what we're looking for is a pinkish color to show up once these 2 tablets have dissolved. And so we'll do a reading on this in just a little bit after these tablets have dissolved. All right, so now the dissolved oxygen all the tablets have been dissolved, and so I'm going to compare it here to the chart. Notice it's not an 8, it's not a bright, it's kind of somewhere between 0 and 4, which is not really great. It's not bad, but it's not great. Part of it could be because of the hard rains we've had lately and a lot of sediment, dirt coming in, but typically with this pond we normally see it around a 4. So it's not too bad. It's not great, but it's not, gonna hurt a lot of the organisms, because right now I can look out and I can see about 15 snapping turtles. So they're here because there's food. There's a food source, and so that means there's organisms in the water that they can eat. So it's pretty good. Our next test is a phosphorus test, and phosphorus is an element that you'll find on the periodic table. It's naturally occurring, and we use it typically in detergents, in fireworks, and in fertilizers. And again, if you are around an area where there's a lot of people that are fertilizing their lands, or farmers, or golf courses, then the water that runs off will take those chemicals, phosphorus, and they will go into our water streams and our water supply. So again, state park rangers, marine biologists, they run tests to see how much is running and what an effect it might have on our ecosystem. So I'm going to take this little jar. There's a little line right here that tells me how much water I need. I can use my sample bucket, and I'm going to fill it up to that line. Maybe. Get as close to the line as I can. And I'm going to take a tablet. This is called a test tab. I'm going to take a test tab and I'm going to put it in to the water. And again, I'm going to shake and dissolve it, and it will turn a blue color in the presence of phosphates. Now, depending on the rain and what came down and if people are fertilizing, we may see a little higher phosphate content than we normally do, but usually this one has run about a 1 to a 1.5 on the scale here. And you can see the dissolved oxygen scale, you can see the phosphate scale. So every kit would have a scale to show us. And so we shake until it's dissolved. This one's dissolving a little better. And then what we do is we would put it and we would measure against it. And I'm going to let this sit just for a few minutes just to see if it changes to a blue, because there's still a little bit more to be dissolved in there. But what we want is, we don't want it into the 4 range. We don't want dissolved oxygen, down around 0 or anything like that. We want these levels to be kind of in the middle. Phosphates is going pretty good. It's not even a blue color. And so that means that there are no phosphates, which means that as of right now, with the runoff from the storms we've had, we did not get any phosphates flowing down or running off into this area, which would then flow to the Eno. So we've got a pretty okay oxygen level. We've got a really good phosphate level. And so the next test would be our nitrates. And so we'll test for those in just a little bit. This is the nitrate test. And nitrates are found in our human waste, in our animal waste, and in fertilizers. And the one thing about nitrates is they promote growth. So when water sources have high nitrates, you're going to see a high growth in algae and plants within the water. And you may think that's a good thing because plants are good for organisms. But what happens is it takes the dissolved oxygen out of the water. And so then that can harm the organisms living there. The algae begins to take over, and eventually what it does is it actually kills out, the plants kill out the water source. And that's called eutrophication. So today what we're going to do is we are going to test for nitrates. This is a test strip. You can have test strips for pH, hardness, chlorine. There's all types of strips that you can use. We're only going to use what is for a natural area. So I'm going to test for nitrates. I'm going to take this strip, and my directions are on here. I'm going to dip it for 2 seconds, hold it level for about a minute, and then I compare colors. Now I will tell you right now, these test strips have not worked very well for us. They always show no nitrates in the water, so we're not really sure how accurate this is, but this just shows you kind of the things that marine biologist, state park ranger would look for. So we hold it, and then there's actually 2, a nitrates and a nitrites. So I'll hold it here, and then we will, after about a minute, we should be able to read it. Whenever we've been out here at the hub farm, it has always been 0. And that could be because it's kind of a protected area. If I went to a farm where you had hogs or cows and they were free to go into ponds or areas where they could get drinking water, then I would expect to see a high nitrate concentration. So if you go by a pond and you start to see a lot of pond scum, algae growing, then it's probably got a high nitrate or a high phosphate level in it. So this, we've held it for about a minute. This is 0 ppm, which is parts per million. So as we look at our pond today, we run a few tests. I'm not running hardness, chlorine, or the one test that we would also run here is called a chloroform test, and that would test for animal waste. That would test for the bacteria that you find in your fecal matter. The one test we are not running today that a marine biologist, a state park ranger, anybody who deals with water quality would run is the coliform bacterial test. and that test takes several days. But what they would look for is there's a change in a color if there's the presence of the bacteria that you find in animal waste and in human waste. It's good for our system because it helps digest our food, but it's not good when it gets into the water. And if some of you remember in the summertime, if you go to Sandlin Beach at Jordan Lake, no, at Falls of the Neuse, or you go to Jordan Lake, sometimes they will close the beach down during the summer. And there's some areas of the beaches they will close down because they run tests very often, usually about twice a month in the summertime. They run a test to see if these organisms, the coliform, is there, and if they find high levels, they will shut the beach down until the water system has a chance to clean itself out. Because if we ingest it, if we are swimming and we ingest the coliform, it can cause us some serious health issues. And so that's a test that we are not running. Other tests we are not running today include hardness. If you have a well, you would want to run a hardness test. We're not running chlorine because chlorine should not be in this water. Chlorine is added to our drinking water. We are not testing for iron. So if we look at all the results from our chemical testing that we've done on our pond today, the pond is fairly healthy for the organisms that live here. We would not want to drink this water because it has not been purified yet. But our oxygen levels, even though they're not great, and we would like to see them a little bit higher, they're okay for the organisms that live here. As evidence is we've counted about 20-some turtles that are out sunning right now. Our phosphorus levels are good, which means that we shouldn't see a lot of growth of algae or anything. Our nitrate levels, though our test is a little unreliable, I think if it was a really, really high concentration, we would have seen some results. So we're fairly confident that this does not have a lot of nitrates in it. The water temperature is good. And so overall, this pond is very healthy. And when this pond, if we continue to have a lot of rain, flows into the Eno, many of you know the Eno flows into Falls of the Neuse Lake, but Falls of the Neuse flows into the Neuse River, which then goes to the ocean. And one of the things you have to remember is everything that happens upstream, pollution, chemical dumps, waste dumps, will always flow downstream. And so it might not have a major effect on us, but it will on an area way down and the organisms way down. So eventually, if a lot of the upstreams were polluted, we're going to see our rivers, and then we're going to see the ocean become polluted. So it's very important that even though we may think the water source is insignificant, that we keep it clean and we test constantly to make sure we are doing that.